Meteors on the BBC Micro is not only a great game, but also a top project for beginner coders. There are lots of fun challenges and problems to solve and develop our programming skills. So let's build it! Hi there, and welcome to Bytes and Bits. I'm Bob Grant, and this is the Asteroids course. As you heard in the intro, we'll be rebuilding the BBC Micro game Meteors, which is a version of the arcade game Asteroids. Now, this is still a beginner's programming course, but I will be assuming that you have some basic coding skills. If you're very new to coding, then please do have a look at my Learn to Code by Writing Space Invaders course. In that one, I take you through the Space Invaders game, rebuilding it, but very much explaining all of the coding techniques that we use to complete that project. In this particular game here, I'll be assuming that you already know all those techniques. So really I'll be talking you through how we solve the particular problems to build asteroids, rather than teaching you the actual programming techniques. So make sure that you are familiar with TIC80, because that's the programming system we're going to be using in this. And let's get straight into building our game. So I've started up TIC80. We're going to start by just making sure that we put our new project in its own little folder. So I'm going to make a directory called Asteroids. And then I'm going to change directory into that. Okay, so I'm now in my Asteroids directory. And I'm then going to save my game as Asteroids. So really what I've done here is I have created a folder which is going to contain all the code bits and exercises I do for my Asteroids game. So I keep all of that together, and we're now inside this folder. So if I list that now, we can see that we have our Asteroids game in there. So if I now go into my code area, so the title of this game, of course, is going to be Asteroids. And I'm going to put my name in as the game developer. And we're just going to leave that out, and it's going to be in Lua. And then, of course, this is all the boilerplate text we have then for our demo program. And let's get that down. So we now have a totally blank project to work with. And I'm just going to save that, so we have that all ready for us. Now, the first things we're going to do here is, we saw, if you've been through the Space Invaders program, you will have seen then that one of the last things we did in there was looking at game states, where we have a start page, the game itself, and then the end page and dying screens and so on. So I'm going to begin by putting those in, so at least we have the general framework for how our code is going to work. So let me add in that code, and then I'll come back and explain it to you. So that's got 3 game states in play now. So we have a start screen, we have our game playing state, and then our game over state. And really all I've done then is I've created a variable which is going to keep track of what state the game's in. Inside our tick function then, we are checking what state we're in, and then in effect running a different part of the program depending on what state we're in. So this do start screen will, we'll go down there and have a look at it. It simply clears the screen and just prints up a little start message, and then waits for you to press the fire button. Once you press the fire button, we then go into the playing state of the game. In the playing state, at the moment it's just printing up a message and waiting for you to press fire to take you into the end game. And then in the end game, again, it's just another message saying game over. So if we run that, doing Control R, when the start game one, so we press Z to start the game. This will be our actual game playing part, so the actual Asteroids game will be here. And then once we've been killed, we will end up going to the game over screen, and that gets us to the end of the game. So that's got that bit of housekeeping in place. And really what we need to do now is we can do as much as we want with the start and end screens. But for me, I'm just going to leave it as they are with just those simple messages. We can always play with sort of nice graphics and so on at a later date. But we're going to concentrate now on getting the actual game working inside this function. So let me make sure I save my work and let's get started on that. If we have a look at our Asteroids game then, and again we're using the BBC Micro version here called Meteors, we'll see that the majority of our work is going to be in handling these vector graphics for both the player ship and the actual asteroids themselves, and of course the enemy ships when they eventually appear. So it makes sense then that we start work on that to begin with and develop a system where we can actually define and then draw our vector graphics. If we consider a vector shape then, we'll see that it's really defined by a series of points, and we can then simply draw lines between each of these points to give us something, for instance, like the player ship. So our data object in our code will then use these points to model the actual shape. But we'll also need some extra data. For instance, we'll need to have a position on screen, which will define the origin for this particular shape, with our points then, the positions for those being relative to this origin. So the origin and the points then define the shape of our object, but they define it pointing in a single direction. So we need to add in some sort of rotation variable, which will tell us which direction this particular shape is currently pointing in. So now that we have the data which will represent our vector object, we need to have a think about how we're going to code our system to actually draw this and orientate it in the correct direction. So we need to start having a think about some mathematics and some trigonometry which will help us rotate points and work out where we need to draw these lines. So if we consider a two-dimensional space, we can draw in our horizontal x-axis and vertical y-axis. In normal mathematics then, we define the 0-degree angle as being the positive x-axis. So in other words, the horizontal line going off to the right of the origin. We then say that positive angles will rotate you anti-clockwise around the origin. So if we look at the point as drawn on the screen now, and then rotate that around just over 90 degrees, we'll see that we then get to the red point, and we can measure the angle of rotation then at the origin as shown now. So if we think back to the way we're modelling our shape, we've got a local origin, which is the position of our ship on the screen. We then have an array of points, which are all then relative to this origin. Our rotation angle then will give us an idea of how we need to rotate these points to get the final position of the ship. So we need some sort of mathematical formula where we can take a point, the angle we need to rotate it by, and then give us the new point so that we can then plot those on the screen and draw the shape in the rotated direction. So if our original point has the coordinates x1 and y1, and we need to rotate it around the origin by a known angle, then the new position x2, y2 is given by this equation. This idea of rotating points around an origin is obviously going to be a big part of our code. So it makes sense that we're going to need a special function that we can then just simply give it any point and any angle and have it return then to us a rotated point with our new x and y coordinates. And we can then use that throughout our code to do all of our rotation for us. But we do have to be slightly careful. TIC80, as do most other graphics programs, don't use the normal x and y coordinate system. They have the normal x-axis, but the y-axis usually starts in the top left corner, and going down actually is the positive y direction. So when we create our angles then, we will end up having 0 degrees as our normal positive x-axis direction, but now positive angles will actually be clockwise from this, as I've shown on the screen now. So let's come back into TIC80 and we'll start to code this bit of software. Now, if you followed my beginner's course, the Space Invaders one, you'll know that in that one I really did type out things as we went along so that you could follow my typing. In this one here, we're going to take it a bit faster, where I'm going to say what I'm going to make, or what bit of software I'm going to write. I'll then put that in and then explain it afterwards. So we're not going to go through the long process of watching me type everything in. So I will still explain everything, but I'm expecting you to be at the state now where you understand the general structure of our software, and I don't need to explain a lot of the actual individual statements. Also, it means then that as we come to pieces, each bit, really, you should have a go at doing it yourself to begin with, and then compare it with what I've done just to make sure that we're heading in the right direction. After each bit of code then, I will show you what I've typed in on the screen, but I'll also make the full listing for each lesson available on the project pages that go with this lesson on my main website, the bytesandbits.co.uk website. And again, if you're viewing this on YouTube, just simply have a look in the video description below, and I'll give you a link off to that project page so you can get the listing and type that in if you need to. So let's make a start on that. And really we need to do, the first thing then is to define our player ship. So I'm going to create an object, well a Lua table which is going to simulate an object, and we're going to call it player ship. So we're going to fill that bit in first. And this is really where you should be having a go yourself. I'm going to put in a pause where you can now stop the video and have a go at typing in your own version of the player ship, and then check back with me after I've put in that countdown. So our player ship object then consists of, it's a Lua table, and we're creating inside that then another Lua table to act as an object to hold the position information for x and y coordinates, our rotation attributes, and then another Lua table which will hold an array of little Lua objects which each represent then the x and y coordinates of the points on our ship. And again, the points here match up with the image I drew earlier on, where we have the nose of the ship at x8 and y0, and then creating then that triangular points following on from there. And again, the final point then, of course, matching up back with the first point. Okay. So now that we've got the player ship object defined, we need to generate a function which will accept this object. Okay, so this is going to be the general structure of any of our vector shapes. So our vector shape will be an object which contains position information, rotation information, and point information. And our function then will accept this as a parameter and then draw it on the screen. So that's what I'm going to work on next, is the draw vector shape function. So this function needs to accept a single parameter, which will be the vector shape information, and that will be your player ship object coming in. So it contains the position of the ship, the rotation angle, and then this array of points. Now to begin with then, just write the code to draw the shape. So don't worry about the rotation part of it. Just simply get it to pick apart that points array and generate lines by gathering together pairs of points and drawing them on the screen, and again moving them to the position of the ship. So remember, the ship object comes in with a position object with x and y coordinates. So your lines should be drawn relative to that point on screen so that we can actually position the player ship in the right place. So let me give you a bit of a pause here so you can stop the video and have a go at creating that function. Okay, so we have now a draw vector shape function. Okay, and so we have a draw vector shape, and we're inputting as a parameter to this function then one of our shapes. And at the moment then, of course, that is going to be our player ship. But again, because we're going to keep those shapes in that position, rotation, points format, then any shape we pass in here will still be drawn. So the way we're going to do it then is our main bit is this for loop, which is going to loop through every point in our shape.points array. So remember, shape.points was that list of the points that make up the shape. So we're using this idea of this I pairs thing. So we're picking up the index of the point and the point itself using this I pairs function. But what we need to do then is when we get our points, we need to divide them up into lines. And of course, lines have a start point and an end point. So when we first come in, we've only got the first point that we've looked at, so we haven't actually got a line. So what we need to do is we need to have a way of signifying that we're doing our first point. And that means that then we will not actually draw a line the first time round. We'll simply keep a record of where that point was. Because what we're going to do is as we move on point by point, we're going to draw a line from the last point to the current point. Right? So on our first go through, we simply make a note of where this point was, so that becomes the last point we dealt with. And the next time through our loop then, we come to here, and we will say then we're going to draw a line. So from our last point, okay, so our last point X and our last point Y, we're going to use the position values of our shape to make sure it goes in the right part of the screen. So remember, all of our points are referenced to the origin within our shape. That makes it easy for us to rotate it around. So again, I haven't put the rotation bit in yet on this. We're then going to move it into the correct position on screen. And we do that then with the rest of the points. And of course then our line command is start point here, end point here, and line color. And I'm doing it in color 8, which is a bluey color. Then of course we need to make sure that we remember, so this point we're currently working on, that then the next time round will become our last point. And then we have our end of our function. So this should be a function then that works to draw our vector shape, and it will be pointing in the 0 degrees angle, so pointing horizontally to the right. And to make this work, then all we need to do is up in our do play game state function. So remember, this is the function which is called when we're in the playing state. We simply need to make sure that we draw our vector shape and pass it in the player shape object. So let's have a go and see what that does. If I run that and we go and play the game, you can see we now have our vector shape being drawn in the middle of the screen. So coming back out to our code, what we need to do now is to modify this vector shape function and add in the rotation bit. So what we're going to do is when we pick up our point, we're then going to do our rotation calculation on that. And then that's the point we'll then use for our next point and our last point. So we'll always be using the rotated version of our points. So let me add that in, and then we'll come back and see if that works or not. So this is our rotate point function now. So we have our rotate point. It accepts then a point and a rotation angle. So we're then doing that equation we came across before. So our new x position, so the rotated point x position, is the existing point x times the cosine of our rotation minus the y position of our point times the sine of the rotation. And then our y position, of course, then is a similar sort of idea. So the y times cosine plus then the x times sine. And this function then needs to rotate back a point Okay, so remember our points are using our Lua table to create an object. We have an X attribute and a Y attribute, so passing back our rotated coordinates. To make use of that then, if we go back up to our draw function, we had to really just bring in that rotated function, the rotated point now. So we're creating a variable to store our rotated point. At this point, we're calling our rotated point. Let me just switch across to a smaller font size. So we're taking our point, so inside our loop, we're going through every single point. We're then creating a rotated version of that point using our new function, which of course we're passing in the current point we're working with and the rotation of the current shape we're working with. Remember, so at the moment this is the player ship, but it will eventually be our alien, the asteroids and so on. So this time then, if it's our first point, then we simply remember, but we're not remembering the point anymore, we're remembering the rotated version of it. When we come to draw our line, again, we're using the rotated point to give us the X and Y coordinates. And of course then where our last point then is being reset back to this rotated version. So if we run that then, initially then we should get the same that we had before. So we now have our spaceship pointing at the 0 angle. But if I come back in and go up to where I define the ship, so we can see in there we have our rotation. Now, with Lua, the rotation angle is actually in radians. So they go, instead of going from 0 to 360 degrees, they go from 0 to 2 pi. So pi is the same as 180, 2 pi is the same as 360. So if I set it to 3, so that should be a little bit less than 180 degrees. So our ship should be pointing not quite to the left, but a little bit down from the left. So if we run that and press Z, and there we have our ship then pointing at probably around about 170 degrees. Remember, our 0 degrees is horizontally to the right, but our positive angles then are being measured clockwise from that. So we've done a clockwise rotation of about 170. If we come back out again, we can change that round then. If I go to about 5, so that should be almost 270 degrees. And if we run that, we can see we've now got our ship pointing sort of up at about, I guess, around about 290, 300 degrees. So we now have our code, which will let us, if I come down here, so draw a vector shape. The shape that we pass in then, as long as it has an array of points and a rotation value, then this bit of code will be able to draw that. Okay, so again, this is going to be the general format for our vector shape. Okay, and again, a position. So a position on screen, a rotation angle, and then an array of points which are all indexed from the local position. So these points are all relative to the position that our ship has on screen, or it will be our asteroid eventually. So for this one here, for this lesson here, what we're going to do next is just simply put in the left and right command buttons so that we can actually in here, we can press left and right and get our ship rotating. So let me drop that in into our do play game function, and I'll be back in a second. So our check, I've created a function called check player buttons, and that simply then looks, if we're holding down the left arrow key, then that will give us an anti-clockwise rotation, right? So we need to subtract values from our player ship.rotation value. And what I've done here is I have now put a new little variable inside my player ship object called rotation speed. So again, by putting the number in there, it means that if I only have to change one version of it. So if I change the definition inside our player ship, I can then control the rotation speed. Again, we always try to avoid these sort of magic numbers flying around. And then of course, if we do the same for the right function, so again, that's going to give us a clockwise rotation. So I need to add this rotation speed onto my rotation value. And then if we look at our actual game loop, so again, the doPlayGame function is going to be our playing game loop. I've added in an update function here where I simply call my check player buttons function. And if I go up to the top then, you can see there I have added this rotation speed into my playership object definition. And again, this is one thing, you'll have to just sort of play around and tune this yourself. So, but it does mean then that because we're using it as a variable, I simply change this value, and anywhere where I'm using that rotation speed will automatically be updated. Okay, so again, that's the value of using a variable rather than typing the number directly in whenever you need to use it. So let's give that a go and see what happens. So in here, and now if I do my left and right buttons, you can see now we have our ship able to rotate in our two-dimensional space. And that seems to work pretty well. Okay, so now there's one last thing which we probably should have a look at with this. And if I come back into my code and go down to my check player buttons thing. So you can see here we are updating our rotation speeds, so our rotation angles. And at the moment then, we're simply just adding and taking away values from that. But what that means is that the actual value being stored in our rotation variable will of course either get very large or very small. So we're not limiting it at all. So we know that our angle is measured in radians, which go from 0 to 2 pi. And it would be sort of good practice to keep it inside that range, rather than if somebody holds down the right key, and we'll simply keep adding to our rotation angle, and that will eventually just sort of spiral up and get larger and larger and larger. So what we should really do is at the end of this function then is we should really limit that angle and keep it inside that 0 to 2 pi range. And again, if the player hits the left button and we go negative, then we can of course pull that angle back into that 0 to 2 pi range so that we don't really deal with negative angles as well within our system. And that will just make things a bit easier for us to understand. So let me add that bit in, and then we'll see how I did that. So I've now created a little function which will keep our angle in this range, and it accepts in a parameter which is the angle that we want to fix. And basically, if the angle is less than 0, so if the angle has gone negative, then all we do is we keep adding 2 pi to it until it comes up into our range. Okay, so if the angle is negative, we're doing a little while loop here. So while it stays under 0, we just simply keep adding 2 pi to it. And then eventually that will become greater than 0, and it will then be in our range. Similarly then, if our angle has gone greater than 2 pi, so we've gone more than one full circle, then we do another little while loop. So while it's still greater than 2 pi, we just simply keep taking 2 pi away from it. And eventually that will then bring us back inside our range, and that loop will end. And then our function simply returns back this fixed angle. So up here a bit then. So this is where we are checking our player buttons, and we update our angle with the left and right keys. And all we're doing as a final little bit then is we're resetting our player ship rotation variable to this fixed version. So again, we're using our new function, passing in our player ship.rotation, and that will then be fixed and brought back into our 0 to 2 pi range. And just as a bit of debugging then, just to check that that's actually working, what I've done in our doPlayGame function, so remember this is our main game loop, so just after we draw our ship, I'm actually printing out, so just as a bit of debugging text, up on the top left hand corner, I'm just printing out the value of our player ship rotation angle, and we should find that that then will vary between 0 and 6.2, which of course is 2 pi. It shouldn't go outside that range. So let's run that and see if that's all working. So again, we initially had set that at 5. So if I now start going up, we can see it's getting bigger and bigger. It's 6.05, 6.26, and then goes back to 0 again, and round and back to 0 again. And if I come negative then, so it goes 0.4, a little bit less, and then all of a sudden we hit back into our, it would have gone negative, but of course now it's looped that back round to be our 6.2 radians, which of course is the same as that small negative angle. So we now have our player ship with the rotation, the angle of rotation being kept inside our 0 to 2 pi range, and of course our shape now being drawn from that list of points that we defined in our ship object. So that's probably enough for this first lesson in the Asteroids one, and we've got the main bulk of our point and vector handling code written. So in the next one then we'll start putting some asteroids on the screen and see if we can get some of these objects actually moving then, and getting our player ship, if we can get the thrust button working on that as well. So make sure you save your work. So come out of that, make sure you do a Control S to save your work, and I will see you in the next lesson. Bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.